Hello folks, welcome back to our recorded lectures for HI 121. This is Watching the Skies, Astronomy and its Tools in the Ancient World. So this topic, as well as the next, are a bit different than what we've done so far. Instead of looking at a particular region or period, we're going to be looking at a theme across many regions or periods. So we're doing that in this lecture on Archaeoastronomy. We'll be doing that in the next lecture on the War chariot as well. So in terms of what you should be listening for in lectures that take this format, it's less the specifics of each example, more comparison, contrast, observation of general themes. So why archaeoastronomy? Why talk about this? I added this topic to the course a few years ago. One of the interesting things about ancient societies is that so many of the monuments we have from them have astronomical connections of one variety or another. Now, it's hard to know how to interpret exactly what we see. We're missing the cultural context to a greater or lesser degree, depending on the civilization. But it's important to acknowledge that sky watching was a habit, that celestial events were of great concern to our ancient counterparts. That has implications for how they saw the world, even if we can't fully interpret what those implications were. I mean, something made them spend time and energy creating the precise placements of architectural features. Now, on this slide, that image is the Nebra sky disk. It was buried around 1600 BCE, dates back to 2000 BCE. We believe it is a calendar because it depicts different phases of the moon, as well as the Pleiades star cluster. Now, it was discovered fairly recently, back in 1999, by illegal treasure hunters, and it was recovered by the German government in a sting when it was being sold on the black market. The original looters led the police to the site where they found it as part of their plea deal, so archaeologists were actually able to take a look at the context where the sky disk was found. It's a prehistoric enclosure that was actually oriented to observe the sun setting behind a particularly prominent mountain on the solstice. Now, the disk's actual astronomical significance is obscure, but it's worth pointing out that it predates the beginning of Greek astronomy by 1,000 years. So, we need to look back, way back, actually even farther back than that. Now, archaeoastronomy, where do we start? There are basically two ways of understanding what ancient people thought about astronomical phenomenon. One is by reading their texts, and these can include tables, calendars, observational diaries. There are actually a lot of ancient texts specifically focused on astronomy. Two, we can look at their material culture. So art, artifacts, buildings, devices, all of this has significance. Archaeoastronomy is reference to both ways of pursuing the topic, perhaps with a bit more focus on material culture. But in general, it's looking at the astronomy of past societies in their historical and cultural context. And it's challenging when the material you need is well buried in most cases. Now, understanding ancient ideas about astronomy isn't just done for the sake of understanding ancient astronomy. It also tells us about ancient religion and cosmology, their understanding of the world around them, and what they believed about the impact of celestial bodies on their own lives. Now, in societies where astronomy was a preoccupation of the ruling elite, they looked for signs in the cosmos that would either validate their actions or not when they were trying to decide, when to make war, when to get married, when to make an alliance. The belief was that the gods would give you these signs in the sky if you knew where to look and knew how to look properly, following the correct rituals. Now, this means that there's not much of a line between astronomy and astrology, and that is probably the most important thing to remember about pre-modern astronomy. There really wasn't a line. The belief was that celestial bodies and their movements had impact on us here on Earth. Now, something else to keep in mind is that ancient people would have experienced the sky in a very different way than many modern people would. There is no such thing as light pollution in the ancient world. Has anybody ever seen what the sky looks like when you're well away from any towns or cities at night? My family was huge on camping when I was a kid, and the night sky, when you're camping, for instance, north of Lake Superior, is pretty amazing. I have a slide to show you here. So this is a side-by-side comparison of the sky. On the right is an ordinary night. This is in Mississauga, I think. And on the left is what the same sky looked like during the 2003 blackout. I remember sitting in my backyard in the house I was renting a room in Toronto, just awed at the way the sky looked over Toronto. I'd never seen it like that before. It's like being in Muskoka, frankly. So what we're going to do in this first next little while is just to hit some of the high points of ancient astronomy, to give you a sense of how different societies approached what they saw in the sky. So let's begin by going way back, as I said. And specifically, we're going back to the Neolithic period, the 5th millennium BCE. So we see different cultural groups all over coastal areas of Europe and the Mediterranean beginning to create monumental stone structures. In most cases, they're collective tombs or temples. And the current dating for major megalithic sites ranges from about 4600 to 1400 BCE. There's still a lot of debate over what they're exactly for, but a number of them do seem to be laid out in ways that are aligned with the position of the sun and or the moon at certain times of the year. Now, this requires specific care and construction, so it's unlikely to be accidental. It's difficult to know what the megaliths really mean, and certainly people have speculated all kinds of crazy things about the meaning of, say, Stonehenge. And of course, we have to remember that a lot of these stones would have been moved since they were originally erected. And in many cases, we know that they were re-erected because it's mentioned in the historical record. So one of our best examples of an astronomically oriented site is Bruneboyne in Ireland. And it is made up of 3 great mounds, Newgrange, Nelf, and Douth, as well as a number of other monuments. But the one I really want to talk about is Newgrange. So Michael O'Kelly in the 1980s reset stones, reconstructed the mound, while taking very careful notes on the building sequence, the construction technique, and other details. It is over 45 feet high and 300 feet across, with quartz crystal facing. And O'Kelly discovered a window shaft that he called the roof box. It is 62 feet long, and on the winter solstice, the rising sun illuminates the chamber inside, and specifically a spiral pattern on the back wall. The mound dates to perhaps around 3100 BCE. Now, the 2 other graves in the complex show solstice-related alignments as well. There's a lot of precision here. Slight differences in the angle of the sun illuminate different parts of the passages and burial chambers. So we can ask ourselves, why was that precision important to the people who built it? Now, some of the surrounding stones are decorated. They're called curbstones, and they seem to be arranged in a spiral that marks the passage of the rising sun. And we see that elsewhere in the complex as well. Possibly it's reflecting the perception of a relationship between human life and the cyclical movement of heavenly bodies. They may have had connections to timekeeping. Are they calendars? Newgrange in particular was a grave. We know this. Excavation has turned up pieces of bone and the remains of grave goods. It's been robbed repeatedly, of course, in the last 5,000 years. So whatever its astronomical purpose was, the fact that it also had a religious purpose very clearly has to be taken into account. Now, what Newgrange shows us is that there could be several uses for such complexes. They didn't all have to be designed for all of these purposes from the get-go. These are evolving sites. They are likely focal points for more than one culture. And I remember the first time I taught the history of the Vikings in Ireland, I came across references that the Irish of the 8th century were horrified because the Vikings had broken into Newgrange. Even at that point, it's seen as sacrilege. We don't really know why, but it's interesting that these graves were still revered. So let's give you some pictures of Newgrange now. So there's the mound. There's the burial chamber, and you can see the patterns on the left. And an overhead shot of the mound. You can see the curbstones on the lower side of the mound. All right, now the other megalithic site I want to take a look at is obviously Stonehenge. It's by far the most famous of them. It seems to have been built in 3 phases, beginning about 3000 BCE. I won't get into great depth with them, but basically, phase 1, you get things called the Aubrey holes, which are 36 holes arranged in a circle. The question is, what was in the holes? Was it something that was perishable, like a wooden pillar of some sort? There's a causeway with post holes and a large standing stone known as the heel stone. The causeway seems to have been designed to align with the midwinter sunrise, and the posts were intended to observe the rising of the moon. The Aubrey holes might actually have been used to predict eclipses as a sort of early warning system. They might have held tools of some type. Ancient peoples, we believe, generally saw eclipses as a fairly terrifying portent. I mean, if your society's way of looking at the world is based at all on the idea of the orderly workings of the universe, something like an eclipse breaks those familiar patterns. It cannot be anything but an anomaly to them, at least until they figure out that eclipses come in cycles. Now, the important thing to note here, of course, is that Stonehenge is a pretty complex site, astronomically speaking, even in its first stage. Now, in the second stage, you see the creation of the avenue, which is oriented towards the midsummer sunrise, and there's also the creation of a double ring of stones. Third stage, the double circle is dismantled at some point, and 5 trilithons of sarsen stone are put in. Now, sarsen is the traditional iconic 3-part pillar which you see there in that image. You think of Stonehenge, you think of that shape of stone, right? Now, this stone, by the way, comes from a quarry 20 miles away, and the uprights in the trilithon, well, they weigh up to 30 tons. This is a massive engineering feat. Remember, they don't have heavy machinery, so that when we look at something like this, we know it came at enormous human cost. Now, there are some interesting decorative elements. We see a repeated axe head symbol carved on the stones. There's a big association between the megaliths in the British Isles and the symbol of an axe head. It's interesting to speculate why. The original stones were then set inside a sarsen ring during the third stage. There's an altar stone put in. It's a green sandstone spotted with mica. Now, here's the thing about Stonehenge. There's a ton we don't know about Stonehenge, and yet we are also discovering more about it every day. They are using things like ground-penetrating radar to understand that what we think is Stonehenge is actually just like the tip of the iceberg, and I mean that literally. There's so much more of Stonehenge waiting to be discovered. And there's, some controversy because it's also land that England wants to develop. There's a road that's supposed to go in there. No, sorry, not a road, a tunnel. Now, whatever you want to say Stonehenge was for, it was a tremendous amount of work. It was a tremendous amount of labor and materials. And, why was it that they became involved in this? Why were people willing to work in a low productivity, pre-industrial society to spend valuable time and energy on this? We don't really know. All right, just a couple of slides here. It's a good overhead shot. Okay. That, of course, is the the altar stone. We can't really get that close to Stonehenge anymore. Some people ruined it for the rest of us. Okay. How about Egypt? So we've already discussed that Egyptian religion is organized around the idea of natural cycles. So the movement of the sun and the moon. If you look at Khufu's pyramid, you find 2 shafts reaching from the burial chamber of the king and queen to the north face of the pyramid. We've given you a nice view of Sigma Draconis. Think of this like an avenue by which the souls of the dead could arise to the stars. There are other shafts reaching to the south face. Possibly at the time the pyramid was built, they intersected with something in Orion's belt. So is this star associated with Osiris? It's a good question. I mean, part of the challenge of trying to understand what the astronomical connections are is correcting for changes in the sky, over thousands of years. Our sky is not their sky. Now, there are interesting temples with astronomical connections. The temples of Hathor, the temple of Iris and Dendera. They all had stellar alignments, usually with the star Soptet, or Sirius, as it's better known. At the Temple of Isis, there's an inscription that says she shines her light into her temple in New York, and she mingles her light with that of her father. She mingles her light with that of her father, Ra, on the horizon. So what does that actually mean? It may have been the closest to what they could argue was the pole star at the time, if that sheds any light on the subject. Now, Amun was the patron god of Thebes. In the New Kingdom, he became identified with Ra, hence Amun-Ra. His temple at Karnak has a solar chamber for Ra, with a window through which you could watch the guard at the winter solstice. This is not the only temple of Amun-Ra that does this. The connection between that sunrise and the cyclical movement of the sun god should be obvious. Now, one last particularly interesting example is the temple at Abu Simbel. It was built by Ramses II, and the entrance of the sanctuary welcomes people with colossal statues of gods and heroes. Both the supernatural and the determined, I suppose. Now, we believe that at least one or two of the figures at Abu Simbel are gods. They are lit by sunlight in February and in October. The statue of Ptah, who is a god of the underworld, remains in darkness. There's some real precision here, as well as theological conventions that are, at least in this case, less difficult to try and work our way through. Now, interesting note, the solar alignment at the temple now happens one day later than it originally did, because the temple had to be relocated when the Aswan Dam was created, or it would have been underwater. It was quite the engineering feat to move a temple like that, instead of just to wipe it out. Now, on the small scale, we also see sky maps on the ceilings of tombs. After all, how are you going to follow the sun god on his journey through night if you don't have a road map? So some pictures before we move on. That's the Temple of Hathor in Dendera. The statues at Abu Simbel. Now, we can't point at Egypt and say we know exactly why they took astronomy into account in building their temples, but as we do know more about their religion, our guesses become somewhat more educated, more source material, more context. All right, so what about Babylon? They are the first known writers of systematic text displaying an interest in celestial events. These are the lunar and solar omens from 1700 BCE. They are done for divination purposes. They're observations of the moon, the sun, eclipses, planets, stars. They're all connected to divination. So, if X appears in the sky, then Y will appear at Earth. But we also see them making more mathematical observations as well. In the Neo-Babylonian period, we begin to see astronomical diaries and related texts. They are anonymous, so we don't know who created them, but they are fascinating for the meaning that they see in celestial events. This is obviously a major focus for Byzantine scholars going forward. I just happened to see some pictures of them online. I thought they were quite cool. Now, one of the things that looking at Babylon emphasizes, again, is that we cannot separate astronomy from a belief in astrology, not in the pre-modern world. You can't do it in the ancient world. You can't do it in the medieval world. The secular world is still winning out here. Now, it makes sense if you think about it from their perspective. If you believe you're part of a greater system where all bodies exert force on one another, then of course celestial bodies will affect you. A sort of supernatural force of gravity. Now, Babylonian astronomers observed the moon. They figured out its cycle. They also observed Venus, which they call Nindarana. Now, Babylonian astronomers moved generally towards more precise measurement. This leads to an accuracy of about a minute, at least in some cases. They recorded private and public birth dates. And I think, all of us could probably to follow the same. But you need the birth date in order to be figuring out where your stars were when you were born. Now, later in Babylonian history, the astronomers focused more on linking their observations to omens again. So, interestingly, a stronger incorporation of this by the books, by the facts alone approach, rather, helps people to develop their scientific authority, but really doesn't do much for the human side of all of this, I would argue. Something that might have helped. Some of our earliest records of Chinese astronomy are found on what we call oracle bones. These can be either animal bones or turtle shells that are cracked with a hot knife. The cracks are then used to help divine what choices a king should make when it comes to affairs of state. They do record usually what the divination was for, as well as the results, so they're fun sources for ancient China. We see a lot of discussion of eclipses. This is used against the Chinese, who are told by certain types of thinkers that they haven't had enough eclipses to become mature men. It's always mature men, right? Now, the Chinese mindset didn't really go harmoniously with this. They had a very complex set of ideas about scientific and divinatory sky watching. The scientific sky watching included regular calendrical cycles, while divinatory sky watching focused on anomalies that would have had special circumstances to them. Now, there are different types of practitioners even within these two separate traditions. The state astronomers produced almanacs, when is a good day to travel south to this city, etc., etc., where do we stay along the way. Astrologers, in contrast, watched for portents, but as an emperor you needed to have both working for you, or you would fail as an emperor. Now, around the year 0, the Chinese developed their equivalent of the Saros cycle, which is the way in which the classical world was able to tell when an eclipse is coming. So because of this, the eclipses had to be moved from the domain of omens into the domain of calendars. There's no more significance for omens if they're taught. And they also developed a system of 28 lunar lodges, which was a way of dividing the sky into 28 regions, centered around specific stars or constellations, not all the same size. Now, I noted the importance of the emperor's role in preserving order. It's a little later in history that this also included carrying out specific connections at the solstices, smoothing the transition between the sorcerer's holiday, if you want to call it that, and the Christian holiday that was replacing it. I'm not going to get too deeply into China because we'll church stuff a little bit later on in the year. But it's worth noting that the nature of Chinese astronomy in particular strongly reflects the nature of their culture. It's a good lesson in how science doesn't emerge separately from whatever context that birthed it, but instead that there's this hummingbird form out there that I'm really not yet. Okay, thanks very much, guys. I am going to go and record the other one now. Catch you then.